Hello, this is video for mathematics for game programmers, module transforms. This video is part 2, and next I will answer this how transformation order works, and I will demonstrate with this scene graph builder, and I will link to add link to this page. So we have this shape nodes here, like square, and we can add these transform nodes to that shape. So we have this scale, transform, rotation, and translate. And I link these from that root node. So we get the square here, and now I can translate it by x and y axis and rotate it and scale it by x and y axis. So all seems work nice with this order, but if I change the order, the behavior come unexpected. So if I change this translate node to first node from the shape node and link again, okay, it must be done this way. And now if I try to translate, it goes by different axes, like kinda like local axis instead of world axis like it was before. And if I scale, scale seems to work. And rotation goes slightly different way. If I change this translate more, I think that scale will change, like this, the center point or that offset will rise. And for scaling, same thing. So it goes this unexpected behaving when this order is not the specific order. So the order must be in a specific way to get the expected behavior. So the right order must be from the shape. First must be the scale, then the rotate, and lastly the translate, counted from shape. And that hopefully answers that question. Next I will answer this question, how scene graph or transformation graph works. And first I will determine what is the scene graph, what it means. The scene graphs are conceptual tools used to represent virtual three-dimensional worlds in computer graphics applications. And the scene graph is a hierarchical structure containing nodes and edges which connect those nodes. And the nodes of the scene graph manage the data describing a virtual scene. So it can be like 3D models and how they behave, like 3D model of the head, how it rotates and so on. The edges that connect the nodes describe the relationships that exist between them in meaningful way. Like if you have 3D model of the hand, the whole hand, the nodes can be described the rotation and movement of the whole hand, or just the wrist or elbow or such. And the nodes are ideally arranged in a hierarchical manner that corresponds spatially and semantically the modeled object or world. So I can show you this application, scene graph application again, and here we have this robot scene graph for the robot, and this would be the scene graph for the 3D models of this robot object in that 3D space. And here we have those nodes. The nodes are these circles, and the edges are these lines connecting those circles. And the hierarchical order is clearly shown here, like this root node is the father of all these nodes, and it paints all this robot. And if we just select this, like this arm connected node, it just select this arm. So here are different nodes, like this translate nodes and rotation nodes and scale nodes also. And these nodes can be grouped to the logical way, like head and neck can be one group, or legs and these foots. And all the nodes goes all the way to those objects which would contain the 3D model. So if we select the most top of the hierarchy node, we can move this whole object at once, and we can go more specific parts by going downwards, this like moving focusing on just for the moving the arm or rotating it, or like the legs we can just affect this one part of the robot, and further down we go the more specific parts we can manage. And yeah, I think so. It's just this hierarchical way to add nodes to every object, can have this translate and rotation and scaling, and one from selected node it controls all the its child nodes. And yeah, hopefully that's answered that question. And that concludes this video. Thanks you for watching, and bye.